The plant site is a vast industrial complex covering more than 320 hectares, or about the size of 250 football fields. At the plant site, the ore undergoes numerous steps, collectively known as the hydrometallurgical process, which ultimately yields refined nickel and cobalt. As indicated by its name, the hydrometallurgical process makes use of water and other chemical compounds to progressively separate nickel and cobalt from the other materials present in the ore. Upon arrival at the plant site, the slurry enters a thickener, essentially a very large tank where solids are allowed time to settle out. The thickened slurry next moves into a battery of 5 extremely large vessels known as autoclaves, which are effectively enormous industrial-scale pressure cookers. It's in the autoclaves that the hydrometallurgical recovery process, a time-tested technology developed and perfected over the last 50 years, truly begins. Inside the autoclaves, the slurry is heated and pressurized, and then mixed with sulfuric acid as part of a process known as pressure acid leaching, or PAL. In the autoclaves, the temperature of the mixture is raised to 250 degrees Celsius and subjected to 5,000 kilopascals, or 50 times normal atmospheric pressure at sea level. The combination of sulfuric acid and high temperature dissolves the nickel and cobalt into a liquid solution. Undissolved solids, mainly iron oxide, remain in the slurry. To prepare the slurry for further processing, it must now be neutralized. This is done by the addition of limestone, making gypsum precipitate. The neutralized mix is then decanted progressively in a series of large tanks. In these tanks, the solution containing nickel, cobalt, and other minerals is separated, and unwanted solids settle to the bottom. Materials with no economic value are treated and pumped via a 15-kilometer pipeline to a 750-hectare tailings facility, a secure, stabilized area where neutralized waste products from the plant site are placed for permanent safekeeping. The tailings facility has been built to specifications consistent with the requirements of the International Finance Corporation. Over the 30-year life of the project, the tailings facility will be progressively filled with inert waste materials and covered by shallow lakes, the surface of which will gradually rise as the tailings continues to be filled. Eventually, these shallow lakes will disappear and the area will be reclaimed to resemble the surrounding terrain. At the plant site, decanting and neutralization continue by the addition of limestone. Gypsum precipitates, as well as impurities such as iron, aluminum, and chromium. Nickel and cobalt remain in solution with other dissolved impurities, such as calcium magnesium, sodium, and manganese. To separate still other minerals, the solution is heated and mixed with hydrogen sulfide. This causes the metals to solidify as metal sulfides. These metal sulfides now move on to the adjacent refinery for additional processing. The purpose of the refinery is to separate the nickel from the cobalt and to bring both to industrial levels of near complete purity. Many extractive industries in sub-Saharan Africa have chosen to refine their minerals in Asia, Europe, or North America. Ambatovy's decision to fully refine its nickel and cobalt in Madagascar entailed an additional investment of $800 million and guarantees more than 1,000 jobs for Malagasi's for at least the next 3 decades. The first step of the refining process is to return the now solid materials back into a liquid state. Residual iron, aluminum, copper, and silica are then removed through a variety of processes, including precipitation, sedimentation, and filtration. Residual zinc is removed by the addition of ammonia, and nickel and cobalt are separated by solvent extraction using organic solvents, creating 2 purified solutions, one containing nickel and the other containing cobalt. Hydrogen gas is added under high pressure to these solutions, which causes the nickel and cobalt to precipitate into a solid form. Following cleaning and drying, the fully refined nickel and cobalt are heated and compacted into small briquettes for shipment. Through evaporation, the residual solution from the refining process is crystallized into ammonium sulfate, an agricultural fertilizer in wide use around the world.